In Chapter 7 here, we are all about integration. We want to develop some more techniques for integration. We really only had our basic integration rules and then use substitutions at the end of Calc 1. So here we want to develop lots of other methods to find the integral of a function, and then we'll apply those in the next chapter. So I'm going to start off by asking you to recall the product rule, which said that the derivative of a product, f of x times g of x, is f prime g plus f g prime. Well, let's take integrals of both sides here. So if I integrate the left-hand side right here, then that should be equal to the integral of the right-hand side. And notice here on the left-hand side, I took a derivative and then I took an integral, and those are going to cancel each other out because they're inverse operations up to a constant. Might have an extra constant floating around, constant of integration. So our left-hand side now is f of x times g of x. And on the right-hand side, I'm going to integrate each piece here, f prime g, and then integral f g prime. So now I am going to take this integral here, and I'm going to bring it over with the f of x g of x. So I've got my f of x g of x minus the integral, and I'm writing it as g f prime dx. And then this integral is right here. It's by itself on the other side. So now I'm going to do a u substitution. I'm going to let, actually two, I'm going to let u equal f of x and v be g of x. Then my differential here will be f prime of x, the derivative, times dx. And then if v is g of x, then dv is going to be g prime of x times dx. So then what do we have here? Well, here's our f of x, that's a u, and then our g prime of x dx, that is our dv. And then f of x is u, g of x is v, and then g of x here is v, and then f prime of x dx is du. So I can abbreviate this as the integral of u dv is uv minus the integral of v du, and that is what's called the integration by parts formula. So with integration by parts, you don't actually do the substitutions, but what you're doing is you're taking an integral of this form, u dv, and you change it into a product of functions minus an integral of the form v du, and we hope that this integral here is an easier integral to work. That's what we hope anyways. And you can do integration by parts for definite integrals. So integral a to b definite, you just evaluate your product from a to b and evaluate your second integral from a to b. So let's talk about how to carry this this integration by parts thing out. The keys here are to pick u so that it has a simpler derivative, because you're going to replace it with du over here on the right hand side, and pick dv so that it's easy to integrate. So for example, let's say we want to integrate x minus 2 times 3 to the x dx. So I want to pick my u and my dv. And so I could pick the u to either be the x minus 2 or the 3 to the x. If I differentiate x minus 2, I'd get 1, so that's a simpler derivative. You differentiate 3 to the x, you get 3 to the x log 3. Not simpler, not more difficult, but not simpler. So let's let u be x minus 2, and then our dv is going to be the 3 to the x dx. And that will have taken up the entire integral here. So here is our u, and then the 3 to the x dx, that's our dv. So then we're going to rewrite this. We first have to find our du. Derivative here is just 1 times dx, so du and dx are the same. And then v is going to be the antiderivative of 3 to the x. So antiderivative 3 to the x dx. And remember here, when you differentiate b to the x, you multiply by log of the base. When you integrate, you divide by log of the base. So this is 3 to the x divided by ln of 3. And then you would have a plus a constant, but we're going to take the easiest constant, 0. Now, you don't have to write the integral sign out here. If you don't want to, you can just actually do the antiderivative. So then up here, we want to go ahead and rewrite uv minus integral of v du. And we hope this is an easier integral. So our uv, so that's this product here, x minus 2, and then 3 to the x over ln 3, so x minus 2, and then 3 to the x over ln of 3, minus integral v du, which is the bottom row here. So we have 3 to the x dx times, 3 to the x over ln 3 times dx. And lo and behold, this is now an easier integral than what we started with here. We don't have that polynomial out in front. So we can actually factor out the ln 3, and then we'll just be integrating 3 to the x. So in the next step, this will be x minus 2 times 3 to the x over ln of 3 minus, we'll pull that log 3 out in the denominator, and then we just got integral of 3 to the x dx. So this will be x minus 2, 3 to the x over ln 3, and then minus, we've got that 1 over ln of 3, and then antiderivative or indefinite integral here is going to be 3 to the x, and then divide by log of the base again, so divide by ln 3, and now we will go ahead and add our constant of integration, plus c. So, and then we could do a little more simplifying. We've got 2 factors of log 3 on the bottom, so we could factor this one out here. We've actually got a common factor of log 3 there, so we could do a little bit of factoring to simplify, but our integration is done. And if your first try for u and dv doesn't work, then try again, switch them, and see if it works better.